Imagine a silence so absolute it's deafening, a void where there is no air, no medium, nothing to carry a single vibration. This is the space we think we know. But what if I told you that silence is a lie? What if, within that hollow blackness, there is something astronauts have described as music, eerie whistling, or even screams? Welcome to a story that might keep you awake tonight as we uncover one of the most unsettling mysteries in the history of space flight. Today we're talking about the sound of space, a phenomenon that baffled NASA for decades and, if rumors are to be believed, pushed even the most elite pilots to the brink. We'll go inside declassified archives, look at the hard data, and try to answer the impossible. Is it a physical reality, a hallucination born from extreme isolation, or something else entirely? Get ready. We're heading to the far side of the moon to hear something that was never meant to be heard. Our story begins in May 1969. Just 2 months before Neil Armstrong's historic lunar landing, the crew of Apollo 10, Thomas Stafford, John Young, and Eugene Cernan were performing a final dress rehearsal. Their mission was to orbit the moon, test every maneuver, and return safely to Earth. As their command module, Charlie Brown, slipped behind the far side of the moon, they lost all contact with Houston. It was expected, a standard procedure, leaving the 3 men in total radio isolation from the rest of humanity. But then in that crushing silence, their headsets suddenly filled with a strange, otherworldly noise. It was an eerie, whistling melody that lasted for nearly an hour. The astronauts were stunned. They whispered among themselves, trying to make sense of it, even joking about whether they should tell Mission Control, fearing that if they did, NASA might think they'd lost their minds. Those recordings remained classified for decades. It was this very incident that birthed the legend of space music and forced scientists to completely rethink the nature of sound in a vacuum. So, what exactly was this space music that the Apollo 10 crew encountered? In the now declassified audio, you can hear the genuine surprise and even a hint of unease in the astronauts' voices. "You hear that?" one asks. "It sounds like, well, outer space-type music," another replies. They described it as a high-pitched, whistling sound, a strange, eerie howl that ebbed and flowed like a ghostly melody. It didn't sound like typical radio interference or mechanical noise. These were seasoned pilots and engineers. They knew every hum and rattle of their spacecraft. This sound was something entirely foreign to them. To understand why it was so unsettling, you have to consider the context. They were 60 miles above the far side of the moon, completely shielded from any radio signals from Earth. They were utterly alone. This isolation gave the encounter a haunting, almost mystical quality. They even debated whether to report it to Mission Control at all. "No one will believe us," Eugene Cernan said. The fear of being misunderstood or labeled as unstable due to the isolation was so strong that they nearly kept the incident to themselves. Fortunately for history, every word was captured by the onboard recorder. Those tapes remained classified in NASA's archives for nearly 40 years, fueling decades of rumors and conspiracy theories about what the agency might really be hiding from the world. When news of the Apollo 10 incident leaked and was later officially declassified, it sparked a firestorm of speculation. Theories ranged from the plausible to the purely fantastical. Some suggested these were signals from an extraterrestrial civilization attempting to contact humanity's first emissaries to the moon. Others believed the astronauts had encountered an unknown physical phenomenon unique to deep space. NASA's long silence on the matter only added fuel to the fire. The scientific community, however, remained skeptical. Their argument was simple. Sound, as we know it, consists of mechanical vibrations traveling through a medium like air or water. In the vacuum of space, there is nothing for those waves to move through. According to the laws of physics, hearing anything outside the spacecraft is impossible. This led researchers to look for answers inside the ship rather than out in the void. For years, the leading theory was radio interference. The idea was that the strange noises were the result of the radio systems in the lunar module, Snoopy, and the command module, Charlie Brown, interacting with each other at close range. Yet even this didn't quite settle the debate. It failed to explain why the sounds were so melodic and hauntingly organized, rather than just random chaotic static. Let's take a closer look at this story's biggest scientific paradox: sound in a vacuum. Space movies have conditioned us to expect roaring engines and thunderous explosions, but in reality, space is silent. A sound wave is essentially energy being transferred through colliding molecules. In a vacuum, molecules are so far apart that this transfer just can't happen. Think of it like a pool table where the balls represent molecules. If they're packed tightly, hitting one sends a ripple through the whole group. But if there are only a few balls scattered far apart, hitting one won't affect the others at all. Space is like that nearly empty table. Does that mean space is completely mute? Not exactly. This is where electromagnetic waves come in. Unlike sound, waves like light or radio don't need a medium to travel. They move through a vacuum with ease. And here's the fascinating part. Space is literally buzzing with these waves generated by stars, planets, and nebulae. Our ears can't pick up radio waves directly, but we have technology that can capture them and translate them into something we can hear. That's exactly what radio telescopes and deep space probes do. So when we talk about the sounds of space, we're almost always referring to data sonification, the process of turning electromagnetic vibrations into audible sound waves that we can listen to and study. So, what really happened aboard Apollo 10? Was it truly just radio interference between the two modules? While that explanation seemed the most plausible at the time, it had its flaws. For starters, Apollo 11 astronaut Michael Collins, who orbited the Moon alone while Armstrong and Aldrin were on the surface, reported hearing similar strange sounds. But Collins was alone in his module. There was no second craft nearby to cause interference. This cast serious doubt on the interference theory. Furthermore, even NASA engineers admitted that the character of this music wasn't typical for simple static. This is where a more modern and sophisticated hypothesis comes in, involving plasma and magnetic fields. You see, while space is a vacuum, it isn't completely empty. It's filled with charged particles, plasma, streaming from the sun as solar wind. When this plasma interacts with planetary magnetic fields, it creates complex electromagnetic phenomena. These vibrations, known as plasma waves, can be picked up by a spacecraft's radio antennas. Then something fascinating happens. The ship's electronics can unintentionally convert these radio signals into the audible range, sending them straight into the astronauts' headsets. In other words, they weren't hearing sound traveling through a vacuum. They were hearing the interaction between the cosmic environment and their own equipment. It was the natural music of the cosmos, played across the strings of their spacecraft's antennas. Confirmation of this theory came from the depths of space, courtesy of two legendary probes, Voyager 1 and Voyager 2. Launched back in 1977, these spacecraft were equipped with specialized instruments designed to record plasma waves. As they trekked past Jupiter, Saturn, Uranus, and Neptune, their sensors captured a staggering array of electromagnetic vibrations within the magnetospheres of these gas giants. When NASA scientists converted these recordings into audio, the world was stunned. We heard what researchers described as the chorus, whistles, and hiss of the cosmos. Each planet had its own unique voice. The recordings from Jupiter sounded like dolphins or some kind of celestial birds. Saturn, on the other hand, emitted eerie, pulsing tones that seemed pulled straight from a horror film. These aren't sound effects or fantasies, they are real data. They prove that space is teeming with electromagnetic activity, which can be heard if you have the right tools. The Voyager missions showed that what the Apollo astronauts experienced wasn't unique to the Moon. It's a universal phenomenon that occurs anywhere plasma and magnetic fields interact. In essence, these spacecraft act as giant ears, allowing us to listen to the symphony of our solar system. Though these sounds have been translated for the human ear, they carry vital scientific data regarding plasma density, magnetic field strength, and the complex processes unfolding millions of miles from Earth. Now let's step away from the physics for a moment and talk about psychology, because it's one thing to look at objective data from Voyager's instruments, but it's quite another to consider the subjective experience of a human being, confined to a cramped capsule hundreds of thousands of miles from home. Long-duration spaceflight is a profound test of the human mind. Astronauts undergo rigorous screening and years of training to prepare for such extreme environments. But even the most resilient person is still human. In space, the primary psychological enemies are isolation, sensory deprivation, and constant stress. Imagine living and working in a confined space for months on end with the exact same people. Outside the window, there is nothing but an endless black void and distant stars. Your entire connection to home, to your family, and to the planet itself is reduced to a radio signal with an agonizing delay. The pressure is immense. Under these conditions, the brain, deprived of its usual stimuli, starts to behave in strange ways. It tries to fill the void. This phenomenon is known as sensory deprivation. The mind begins to generate its own sights, sounds, and sensations. This can manifest as mild hallucinations. You might think you hear faint music, footsteps, or distant voices. This isn't a sign of madness. It's a normal reaction of the nervous system to an entirely abnormal environment. So, when we analyze stories from astronauts about hearing strange sounds, we must always keep this powerful psychological factor in mind. There's actually a specific term for the way our brains search for familiar patterns in chaotic data: pareidolia. Most of us know it as seeing faces or animals in the clouds, but the same phenomenon applies to sound as well. This is called auditory pareidolia. When we listen to random noise like the steady hum of a fan or the static on a radio, our brains desperately try to find some kind of meaning or structure. We might suddenly pluck something out of the chaos that sounds like a melody, a voice, or a faint whisper. Now consider the environment of an astronaut. They are constantly surrounded by the monotonous drone of life support systems, clicking relays, and radio hiss. Combine that with the effects of stress, fatigue, and total isolation, and the brain becomes hypersensitive to even the smallest anomaly. When the ship's antenna picks up real, chaotic electromagnetic fluctuations from space, an astronaut's mind may interpret them as something structured, like music. This doesn't mean the sound wasn't there. It was real. No, perceiving it as something organized and melodic is entirely the work of our own consciousness. It's a remarkable intersection of physical phenomena and subjective perception. Space truly does sing, but we only hear the song because our brain acts as the composer, arranging random notes into a melody, into. Whispers of space madness have been around since the dawn of space travel. Pop culture loves the trope of an astronaut staring into the infinite void and losing their grip on reality. But how much of that is actually true? The reality is that NASA and other space agencies take mental health incredibly seriously. The selection process involves rigorous psychological screening designed to weed out even the slightest hint of instability. This is followed by years of preparation, including long-term isolation in underwater labs or remote Antarctic stations. Astronauts are trained to work as a team, resolve conflicts, and manage the intense stress of long-duration missions. Even during a flight, their mental state is constantly monitored by professionals back on Earth. Of course, there have been challenges along the way. Some crew members have dealt with periods of depression, irritability, or trouble sleeping, perfectly human reactions to such an extreme environment. But in the entire history of spaceflight, there hasn't been a single confirmed case of a major psychotic break in orbit. Ultimately, the idea of space madness is a myth, fueled more by our own fear of the unknown than by facts. Astronauts aren't emotionless superheroes, they are highly skilled professionals who have mastered the art of staying focused and composed under unimaginable pressure. But history holds other, equally mysterious acoustic anomalies in space. One of the most famous cases involved China's first taikonaut, Yang Liwei. During his maiden flight aboard the Shenzhou 5 in 2003, he heard a strange noise. Liwei described it as sounding like a wooden hammer striking an iron bucket. The sound appeared out of nowhere, without any apparent cause, and was completely unlike the routine, mechanical hum of the spacecraft. He peered out the porthole but saw nothing that could have made such a noise. The sound was so unsettling that upon returning to Earth, he gave a detailed report to his engineers. Technicians tried to recreate the sound by simulating various conditions, but they couldn't find a definitive explanation. Yang Liwei's story is particularly fascinating because it differs so much from the Apollo 10 experience. It wasn't a whistle or space music, but a sharp, mechanical knocking. Crucially, other Chinese astronauts reported hearing the same sound on subsequent missions. This suggests the cause wasn't psychological, nor was it some strange space plasma. Today, the most likely theory is structural deformation. When a spacecraft moves in and out of the Earth's shadow, it faces extreme temperature shifts, causing the hull materials to expand and contract. This process can produce sharp, popping or knocking sounds. While that explanation may seem mundane, it perfectly accounts for the nature of the noise and why multiple crews on the same type of spacecraft all heard it. Now let's return home to Earth. Believe it or not, our own planet is one of the most intense sources of cosmic sound in the solar system. It all starts with Earth's powerful magnetic field, which shields us from harmful solar radiation. This protective bubble, called the magnetosphere, extends tens of thousands of miles into space. When the solar wind, a stream of charged particles from the Sun, buffets the magnetosphere, a spectacular interaction occurs. Think of it like a gust of wind plucking the strings of a harp, where Earth's magnetic field lines are the strings. This produces powerful electromagnetic waves that we can actually record. Scientists have given these phenomena names like chorus, hiss, and whistlers. A chorus is a series of rising tones that sound uncannily like birds chirping at dawn. These very waves are believed to trigger the auroras as they guide charged particles toward the poles to collide with our atmosphere. Then there are whistlers, low-frequency waves sparked by lightning strikes. The energy from a single bolt travels along magnetic field lines from one hemisphere to the other, creating a signature descending whistle caught by our instruments. These sounds aren't just a cosmic concert, they're vital pieces of data. By listening in, scientists can monitor the state of our magnetosphere and track space weather, the solar activity that can disrupt our satellites, communications, and even power grids back on the ground. Beyond the theoretical sounds of space, there is another constant source of noise, the spacecraft itself. The International Space Station, or any crewed vessel, is a massive, complex machine that never truly goes quiet. Imagine living inside a giant engine room that runs 24 hours a day. You have the constant hum of life support fans circulating the air, the steady whir of coolant pumps and the rhythmic clicking of valves and relays. Even the exercise equipment adds its own vibration to the mix. On the ISS, this background drone stays around 60 to 70 decibels, roughly the same volume as a running vacuum cleaner. Astronauts say you eventually get used to the noise, but it never really goes away. In fact, many have to wear earplugs just to get some sleep. Against this steady white noise, any sudden sound, a creak, a pop, or a knock, instantly grabs your attention. The crew is trained to listen to their home, knowing that one unfamiliar noise could signal a mechanical failure. That famous knocking sound reported by astronaut Yang Liwei was likely just the sharp crack of thermal expansion, cutting through the usual hum. In the end, the acoustic world inside a spacecraft is a complex soundscape, a blend of monotonous mechanical drones and rare, sometimes unsettling anomalies triggered by the stresses of life in orbit. But could space sounds actually be dangerous? If we're talking about the electromagnetic waves we've been discussing, the answer is no, they're harmless to humans. We spend our lives surrounded by radio waves from TV stations, cell phones, and Wi-Fi routers. Cosmic waves are fundamentally the same, they just come from a different source. The psychological impact, however, is a different story. For someone already prone to anxiety, hearing strange, inexplicable sounds in a high-stress environment can definitely dial up the tension. But there's another, more exotic theory involving infrasound. These are sound vibrations below 20 Hz, too low for the human ear to catch, but not too low for the body to feel. It's well known that certain infrasound frequencies can have a profound effect on the mind. They can trigger feelings of unexplained dread, panic, or intense sorrow, and even cause visual hallucinations by making the eyeballs vibrate. In extreme cases, they can even lead to heart failure. On Earth, infrasound is often generated by heavy machinery, turbines, or ventilation systems. Theoretically, the equipment on board a spacecraft could be doing the same. If an astronaut is exposed to these frequencies over a long period, it might explain some of those odd sensations and psychological discomfort. While there isn't any hard evidence for this in spaceflight yet, it adds a fascinating layer to the mystery of how the cosmos impacts the human mind. How is NASA preparing for these challenges today, especially with long-term Mars missions on the horizon? Psychological readiness has become even more critical than it was during the Apollo era. Future crews won't just be isolated for weeks, they'll be away for years. With a communication delay of up to 20 minutes each way, real-time conversation with Earth will be impossible. They will have to be entirely self-reliant. To prepare, NASA conducts lengthy isolation simulations right here on Earth. For instance, the HIC's project involves volunteers living for months at a time in a specialized dome on the slopes of a Hawaiian volcano, meticulously mimicking life on the red planet. They wear space suits to go outside, eat freeze-dried meals, and operate under a realistic communication lag. Researchers closely monitor their mental health, group dynamics, and their ability to navigate conflict and stress. A major focus of these studies is overcoming sensory deprivation. Virtual reality systems are being developed to allow astronauts to visit home, to take a walk through a forest or sit by the ocean. Scientists are also exploring how lighting, scents, and ambient soundscapes can influence a crew's morale. Future spacecraft may even be equipped with systems that generate the soothing sounds of nature to mask the constant mechanical hum of the ship and the haunting silence of deep space. All of this is being done to minimize risk and ensure that the first humans on Mars are physically and mentally prepared for the greatest adventure in human history. Let's return to physics and explore other sounds in the universe that aren't tied to planetary magnetospheres. One of the most extraordinary sources is the pulsar. A pulsar is a rapidly spinning neutron star, the dense remnant of a supernova explosion. These objects are unimaginably compact. A single teaspoon of their matter would weigh billions of tons. Pulsars possess incredibly powerful magnetic fields and emit narrow beams of radio waves from their magnetic poles. As the star rotates, these beams sweep through the cosmos like the light from a distant lighthouse. When such a beam passes across the Earth, our radio telescopes pick up perfectly timed periodic pulses. When these signals are converted into sound, they become a rhythmic, almost mechanical tapping, reminiscent of a ticking clock or a steady drumbeat. When pulsars were first discovered in 1967, their signals were so precise and regular that astronomers jokingly labeled them LGM1, standing for Little Green Men. They seemed almost too artificial to be natural. Of course, we now know their true origin, yet the song of a pulsar remains one of the most captivating phenomena we can hear from the deep reaches of space. It is the sound of a cosmic clock ticking away on a scale that is truly difficult to imagine. But what about the most formidable objects in the universe, black holes? Can they actually make sound? In the traditional sense, no, but even here, modern science has found a way to let us hear them. In 2015, a landmark discovery was made. The LIGO and Virgo observatories detected gravitational waves for the very first time. These are ripples in the fabric of space-time itself, just as Einstein predicted over a century ago. The source of these waves was a collision between two massive black holes that occurred more than 1 billion years ago. Gravitational waves aren't light or radio waves, they are literal tremors in space. But much like radio signals, scientists can translate these vibrations into audio. What they heard was a brief rising tone, a sound now famously known as a chirp. This tiny burst represents a cosmic cataclysm. In a fraction of a second, a mass equal to 3 of our suns was converted into raw energy. It is the most powerful sound ever captured by humanity. Since then, we've detected many more of these events. Gravitational wave astronomy has effectively given us a new ear to the cosmos, allowing us to hear the collisions of black holes and neutron stars and unlocking the secrets of the most extreme processes in our universe. Ultimately, what we called the sounds of space aren't just one thing, but a whole spectrum of different phenomena. On one hand, we have direct physical interactions between the environment and the spacecraft's instruments, as seen with Apollo 10. The ship's antennas picked up natural plasma waves in lunar orbit, which the onboard electronics then translated into audible whistles and hums. This is a very real physical process, later confirmed by data from the Voyager probes and other missions. On the other hand, there's the human element. Under intense stress or in total isolation, our brains naturally try to find order in chaos. We might interpret random static as something recognizable, even music. It's not a hallucination in the traditional sense, but rather the brain creatively trying to make sense of meaningless signals. Finally, there are simple mechanical noises coming from the spacecraft itself, like the knocking reported by Chinese taikonauts. These are often caused by thermal expansion and contraction as the hull reacts to extreme temperature changes. While these sounds have nothing to do with the void outside, they can feel incredibly eerie in such an alien environment. When all these factors intertwine, they create a complex and confusing picture, one that has fueled countless myths about mysterious cosmic sounds driving astronauts to the edge of madness. Let's revisit the transcripts of the Apollo 10 crew. Their reaction is incredibly telling. There's no panic, only a deep, professional curiosity. One of them even mimics the sound, going, "Woo!" They try to classify it, searching for something familiar to compare it to. This is the dialogue of researchers facing the unknown. Crucially, they even question their own perception. The thought that they might just be imagining things is right there in the conversation. They even joke about it. And this shows a remarkable level of psychological training and self-control. They understood they were in an extreme environment where the senses can easily be deceived. Their decision to report what happened, despite their reservations, was an act of pure professionalism. They knew that any anomaly, no matter how strange, could be vital for the safety of future missions. Ultimately, the story of Apollo 10 isn't about astronauts getting spooked by ghostly music. It's a story of high-level specialists encountering the unexplained, documenting it meticulously, and passing it on to scientists for analysis. This is what eventually led to a better understanding of space physics. Their experience wasn't just a strange encounter, it was a vital contribution to science. Today, advanced technology allows us to listen to the universe with more precision than ever before. By linking radio telescopes across the globe, scientists have created a massive virtual array, essentially a telescope the size of our entire planet. These instruments can detect the faintest radio signals coming from the very edge of the observable universe. To process the staggering amount of data these telescopes collect, researchers turn to artificial intelligence. Neural networks are trained to recognize familiar signals, from pulsars and quasars to distant galaxies, while searching for anomalies that might hint at undiscovered phenomena. In many ways, this process mirrors how the human brain finds meaning within background noise. Just as we do, AI sifts through terabytes of cosmic hiss to find hidden patterns. One of the most famous applications of this technology is the SETI program, the search for extraterrestrial intelligence. Researchers scan the heavens for artificial signals, transmissions that simply couldn't be produced by natural celestial processes. So far, every signal we've detected has had a natural explanation. But who knows, one day, amidst the natural music of the cosmos, we might finally hear a deliberate message. If that happens, the mystery of these cosmic sounds will reach a whole new, breathtaking level. We also have to consider the profound cultural impact of these sounds of space. When NASA released the Voyager recordings, they didn't just rattle the scientific community, they captivated musicians, artists, and the general public alike. These haunting, otherworldly tones became an instant muse. Electronic artists began sampling them, weaving cosmic textures into their tracks, while composers penned entire symphonies inspired by these celestial songs. These recordings became the definitive soundtrack to our vision of the cosmos, a place that is mysterious, vast, and profoundly alien. They shattered the myth of a silent void, replacing it with the image of a living, resonant universe. They allow us to do more than just look at the stars. They help us feel the scale of the cosmos on an emotional level. Listening to them is a form of meditation, a way to reach out and touch the sublime. They serve as a humbling reminder of how little we truly know about the world beyond our own, and the staggering discoveries that still lie ahead. In this sense, the space music heard by the crew of Apollo 10 was the opening chord in a grand symphony of human discovery. One crucial detail that's often overlooked is the gap between what machines record and what humans actually hear. Voyager's sensors were built to detect plasma waves with cold, clinical precision. They are objective and unbiased. Human hearing, however, is far more complex and subjective. Our perception isn't just about physics, it's influenced by our anatomy, our expectations, and even our state of mind. Furthermore, the Apollo astronauts weren't listening to space directly. They were hearing it through a long signal chain. From cosmic waves to an antenna, then through a receiver, an amplifier, and finally into their headsets. Every single link in that chain could introduce its own distortions, noise, and artifacts. Because of this, the sound that reached the astronauts' ears likely differed significantly from the original signal in space. It's possible that the musical quality that so surprised them was actually a byproduct of the radio equipment itself, turning chaotic plasma oscillations into something more melodic. It's like listening to a song on an old radio. The static and crackle aren't just interference, they become part of the experience. Ultimately, the mystery of space music is as much a story of period engineering and acoustics as it is a journey into the unknown. Could the Apollo astronauts have mistaken these sounds for something else, perhaps their own bodies? In total silence, you begin to hear things you'd never notice in daily life. Your heartbeat, the rush of blood in your ears, even the rumbling of your stomach can sound deafening. It's an effect well known to anyone who's ever spent time in an anechoic chamber. But these astronauts had spent hundreds of hours in simulators. They knew exactly what silence felt like and how their bodies sounded in that void. Besides, the noise wasn't just in their heads, it was coming through their headsets. Most importantly, multiple crew members heard it at the same time. This rules out individual hallucinations. They were all experiencing the exact same phenomenon. This is the crucial point. It forces us to look for an external source, either out in space or within the ship itself. The internal sound theory simply doesn't hold water here, even if it might explain similar experiences for a pilot flying solo. Let's recap what we know. First off, we can officially put the myth to rest. Sound cannot travel through a vacuum. Physics simply doesn't allow it. However, space is anything but empty. It's full of electromagnetic waves and plasma. When radio antennas pick up these vibrations and we shift them into a range we can actually hear, we get what we call the sounds of space. This is likely what happened during the Apollo 10 mission. The ship's radio gear caught natural plasma waves drifting between the Earth and the Moon, translating them into that strange, whistling noise. As for the astronauts hearing it as music, that's just the human brain doing what it does best, trying to find order in chaos, especially in a high-stress environment. The idea of space madness is another major exaggeration. Astronauts undergo the most intense psychological screening and specialized training imaginable. They deal with incredible pressure, but they don't just lose their grip on reality. Even the mysterious knocking heard on the Chinese spacecraft likely has a mechanical origin tied to the ship's own hardware. At the end of the day, there's a solid scientific explanation behind every one of these mysteries, even if the truth is a bit more complex than the fiction. It's fascinating that you don't need high-tech equipment to hear sounds that seem like they're straight out of deep space. We're talking about atmospheric whistlers, and these are very low-frequency radio waves triggered by lightning strikes. If you're far from the electronic noise of the city, you can actually pick them up with a simple VLF receiver, something you can even build at home. They sound exactly like the whistlers recorded by satellites, a fading chirp that glides down the frequency scale. This happens because as the radio signal from the lightning travels through the Earth's ionosphere, it passes through plasma. In plasma, waves of different frequencies travel at different speeds. The higher frequencies arrive first, while the lower ones lag behind, creating that signature whistling effect. It's a perfect example of how plasma physics, whether here in our own atmosphere or in the magnetosphere of Jupiter, produces the same kind of sonic phenomena. It just goes to show that the music of the spheres isn't some mystical concept. It's a very real and measurable part of radio physics. The future of these studies looks even more promising. New missions like the Parker Solar Probe, which is observing the Sun at record-breaking distances, and JUICE, now on its way to Jupiter's icy moons, are equipped with cutting-edge technology to analyze plasma and magnetic fields. These missions will provide us with clearer, more detailed recordings of cosmic sounds than ever before. This data won't just help us understand the fundamental workings of the universe, it will allow us to predict space weather with far greater accuracy. By analyzing the patterns of plasma waves radiating from the Sun, we can foresee powerful coronal mass ejections that could threaten our satellites and astronauts in orbit. Ultimately, studying this celestial music is about more than just pure science. It is a vital tool for the future of space exploration. Every new note in this symphony brings us one step closer to ensuring our safety as we venture further out into the stars. Let's look at another angle, how these phenomena relate to the search for life beyond Earth. While these choruses and whistlers are natural in origin, the fact that a planet possesses such a complex electromagnetic environment is a major clue for astrobiologists. Having a magnetosphere like Earth's is considered one of the essential conditions for life to take hold and survive. This magnetic field acts as a shield, protecting the planet's atmosphere and surface from the harsh solar wind and cosmic radiation. Without it, any atmosphere would eventually be stripped away into space, leaving the surface exposed to lethal levels of radiation. That's why when we use radio telescopes to scan distant exoplanets, detecting signs of a magnetic field through its distinct radio signature is such a promising discovery. It's a strong indicator that the planet could be potentially habitable. Perhaps one day, when we hear the song of a far-off world, we'll realize it isn't just the music of the cosmos, it's a lullaby for life beyond our own. To wrap up our discussion on sound, we have to talk about silence. For many astronauts, the most profound part of a spacewalk isn't what they see, but the absolute otherworldly stillness. Inside the suit, all you hear is the rhythm of your own breathing and the steady hum of life support. But just beyond the glass of the helmet, there is nothing. It's a sensation they describe as both peaceful and deeply unsettling. It makes you feel the true, staggering scale of the void. This silence is the polar opposite of the cosmic sounds we've been exploring. They exist in two different realms. One is the world of electromagnetic waves, and the other is the world of physical vibrations. An astronaut stands right at the intersection of these two worlds. They can hear the cosmos through their instruments, yet their own ears perceive only the vacuum. This contrast is likely why any unexpected noise can be so haunting. In a world of absolute silence, even the faintest thump sounds like a scream. Should these sounds frighten us? Absolutely not. On the contrary, they should inspire awe. They remind us that the universe isn't some cold, lifeless void, but a dynamic, living system, pulsing with energy and intricate interactions. Every sound we capture is the voice of a monumental cosmic event, whether it's the dance of charged particles within a planet's magnetic field, the final scream of merging black holes, or the rhythmic heartbeat of a distant neutron star. This is the music of matter itself, played on instruments forged by nature. Our ability to hear and interpret this symphony is one of our civilization's greatest achievements. We are no longer just passive observers, we have become the universe's audience. Each new sound brings us closer to unlocking its deepest mysteries, how it was born, how it lives, and what its future holds. So, the next time you look up at the night sky, remember, it isn't silent. It is filled with a breathtaking hidden symphony. Let's revisit the title of our lecture, The Sound That Drove Astronauts Mad. By now, we realize this is a bit of poetic license. No astronaut actually lost their mind listening to space music, but the phrase perfectly captures that raw sense of shock and awe felt by those who first encountered the phenomenon. It shattered the fundamental belief that space is a silent void pushing them far beyond the limits of familiar experience. That cognitive dissonance, heightened by the intense stress and isolation of orbit, was a genuine psychological test. Yet the astronauts rose to the challenge. They didn't succumb to panic or existential dread. Instead, they faced the mystery with the steady resolve of scientists and explorers. In fact, their discovery helped pave the way for entirely new fields in radio astronomy and space physics. Ultimately, the sound of space didn't rob them of their sanity. On the contrary, it expanded the horizons of human knowledge and pushed us to ask even deeper questions about the very nature of our universe. Picture the long-duration space missions of the future. For years on end, astronauts are enveloped in the constant mechanical hum of their spacecraft. But imagine if we could transform raw data from external sensors into a living, real-time soundscape of the environment. This wouldn't just provide scientific insight, it would offer a window into the invisible reaches of the cosmos. Astronauts could actually hear their ship crossing into the magnetosphere of Mars, or listen as the solar wind shifts and swells on the approach to Jupiter. Such a connection to the outside world could bridge the gap of isolation, creating a profound sense of presence within a dynamic, ever-changing environment. Instead of the steady drone of ventilation fans, they would experience the unique, evolving music of deep space. Ultimately, the sonification of flight could become a vital tool for psychological well-being, turning the silence of the void into an immersive and meaningful journey. Ultimately, the story behind the mysterious sounds of space is a perfect illustration of how the scientific method works. It begins with an anomaly, a single, unexplained observation. From there, theories emerge, ranging from the mundane to the wildly fantastic. Each hypothesis is tested, data is gathered, and experiments are conducted. Step by step, the field of possibilities narrows, and where there was once mystery, there is now understanding. What initially seemed supernatural is revealed as a manifestation of the laws of physics, complex perhaps, but real. The mystery doesn't vanish, it evolves. The question shifts from what was that to how does it work? And that is a far more productive question, one that paves the way for new discoveries. The saga of this space music is like a classic detective novel. The global scientific community takes on the role of Sherlock Holmes, piecing together clues gathered from some of the most extreme environments imaginable. And as it turns out, the resolution to this mystery is even more fascinating than the wildest fiction. So, as we wrap up our journey through the sonic landscapes of the cosmos, let's take a look at what we've learned. We've discovered that the mysterious music heard by the Apollo 10 crew wasn't an alien signal or a trick of the mind. It was a real physical phenomenon, electromagnetic plasma oscillations translated into audible sound by the spacecraft's instruments. We now know that our entire solar system is alive with these sounds, and the Voyager probes have captured a literal symphony of the planets for us to hear. We've also seen just how powerful the human psyche can be. Under the extreme stress of isolation, the brain can do incredible things, finding meaning and order even within chaotic noise. Most importantly, we've separated scientific fact from popular myth. No astronaut lost their mind to these phenomena. Instead, their skill and curiosity helped us uncover a universe that doesn't just look spectacular, it sounds spectacular too. The mystery of space sound isn't some supernatural enigma. It's a beautiful intersection of physics, psychology, and engineering, and solving that puzzle has only made the cosmos feel more alive. Thank you so much for joining me as we delved into these NASA secrets. I hope you found this journey as fascinating as I did. If you enjoyed the video, please be sure to subscribe, hit the like button, and share it with your friends. I want to hear from you. What other unimaginable mysteries do you think are still hiding out there? What will be the next great discovery that changes everything we know about the universe? Let me know your thoughts in the comments. I'm looking forward to reading them. Until next time, good night and clear skies.